In this lesson, we're going to solve systems of linear inequalities, and they're going to be in standard form. So let's graph each system of inequality. So let's graph these by using the intercepts. So I'm going to rewrite 2x plus 4y is less than 8. So let's find the x and the y intercepts. And I have 0 and I have 0. So when we plug in 0 for x, I have 4y is less than 8. So when x is 0, y is 2. And then we're going to plug it in for the y now. So let's put our x back there. And so we're going to plug in 0 here. And that goes away. So we have 2x is less than 8. And we'll have then 4. So now let's go ahead, and it's less than, so we're going to have a dashed line. So I'm going to go to 0, 2, and then 4, 0. So we'll have our dashed line. All right, now we have to identify if we're going to shade up or if we're going to shade down. And so in order to do that, we have to go back to our original equation, and we have to plug in, we're going to plug in the point 0, 0. And when we do that, if I plug in a 0 here and I plug in a 0 here, what I'm left with is 0 less than 8. And so we need to ask ourselves, is 0 less than 8? And because 0 is less than 8, that means that it is going to be a solution to the system. And so we know that we're going to shade in that direction on the coordinate grid. So we pick that point 0, 0 to determine if it's a solution, so we could find out which direction we would be shading. So now let's go ahead and we'll graph our negative 2x plus 3y is greater than 6. And so x and y and 0 and 0. So when x is 0, y is 2. And then when y is 0, that goes away. So we're going to have negative 3. So now we need to determine which direction we're going to then shade. And so when you plug in a 0 and a 0, we're going to determine, is 0 greater than 6? Well, because 0 is not greater than 6, that means that we're going to shade in a different direction. So let's go ahead and let's graph then this line. I'm going to have 0, 2, and then negative 3, 0. And again, because it's just greater than, it's going to be a dotted line. All right, and so 0 is not greater than 6, so we're shading in the opposite direction. And so right in here where it's doubly shaded, that is the solution to this system. All right, question number 2. Let's go ahead and we're going to solve these as well by making an XY table and plugging in 0 and 0. We're finding the intercepts. So when x is 0, we have negative 2y is less than 4, so we're going to have negative 2. And then when y is 0, x is equal to 4. So let's go ahead and plot the points. We're going to have 0, negative 2, and then 4, 0. And again, this one's going to be shaded because it is less than. And then we're going to pick our point 0, 0, and we're going to plug it in. So when 0 and 0, is 0 less than 4? Well, because 0 is less than 4, we know that that point 0, 0 is going to be shaded or part of the solution, so we'll shade in that direction. So now we're going to have the 3x minus y is greater than 6. And again, we'll solve this by finding the intercepts. So So we plug in the 0, and then we have negative y is greater than 6. And now we're not going to be switching the symbol or sign at all here because we'll be shading to find out which direction. We just know that we're going to have negative 6 for our x then, and then our y will have 3x is greater than 6, so we'll have 2. So let's go ahead and plot those 2 points. We have 0, negative 6, and then we have 2, 0. And then again, this is going to be a dashed line. Now we need to plug in the points to find out then which direction we're going to shade. So is 0 greater than 6? Well, since 0 is not greater than 6, we're going to shade in the other direction. And then notice that we have this doubly shaded area right in here. And so all those points in there is a solution to this system. All right, question number 3. We have 3x plus 2y is less than 12. So 3x plus 2y is less than or equal to 12. So we're going to make an xy table. So when x is 0, y is going to be 6. And then when y is 0, then we're going to, 12 divided by 3 is going to be 4. So we have 0, 6, and then we have 4, 0. And now this one's going to be a solid line because it's less than or equal to. And then remember, we have to determine which direction we're going to shade. So we've got that 0, 0. Well, 0 and 0. So is 0 less than or equal to 12? And because it's less than, so it's going to be shaded in this direction right here. All right, so we have then our other one. Remember, this is that special kind of equation where you just have one variable. In every case, x is going to be greater than 4. So remember that we're going to, negative 4. So we're going to start at the negative 4. And this is the straight up and down one that goes through the x-intercept. And this is also going to be a solid line because it is greater than. And now normally we would say that we shade up, but we would be shading to the right. We can also do it by plugging in the 0. And is 0 greater than or equal to negative 4? And it is. So then therefore we are shading in that direction. So I'm going to shade this way. And now anything that is in between, all of this in between here, then is going to be the solution to this system. All right, question number 4, we have negative 4x plus 2y. Let's go ahead and we'll solve that one by using our intercepts. So x and y and 0 and 0. So when x is 0, y is going to be 6. And then when y is 0, we divide by negative 4, and we get negative 3. All right, so let's plot those 2 points. We have 0, 6, and negative 3, 0. And this one, because it's just greater than, it's going to be a dashed line. And now we have to determine which direction we're going to shade in. And so plugging in the zeros, is 0 greater than 12? Well, 0 is not greater than 12, so we know we have to shade it in the opposite direction. So we're going to go this direction. All right, our x is less than or equal to 4. Well, that one's going to be, remember, that's a straight up and down line, straight up and down, and it's going to be solid. And then, so then that means that we're going to be shading this direction. Right now, for this one, we're not just looking for doubly shaded lines, we're looking for triply, all 3 of them have to be shaded. And then we have x is greater than or equal to negative 3. So then we're going to have our y is greater than or equal to, so then that's going to be a solid line. and then it's anything that's greater than or equal to. So as we do this, we're looking to see where am I shaded, all three equations, and so it's all of this right in spot right here. So any of those points that you would lie in there would be the solution to this system.